Hi, everyone. Again, my name is Candace Doepker. I'm a toxicologist by training, and my section of the round table is short and a little bit different. I'm going to talk briefly about heat-formed toxicants. So in the toxicology world, we talk about the Maillard reaction a lot, and I hope this slide isn't insulting to anyone. It's sort of simplified, but this is an important reaction in cooking, as probably many of you all know. Non-enzymatic and leads to the nice brown color that we see in our foods and the wonderful taste. Associated with that is also the development of various chemicals of concern. So acrylamide, furan, 4-methyl-imidazole, 5-hydroxymethylfurfural, furfural alcohol. I can go on, and you're probably familiar with some of these chemicals. From a toxicology perspective, zero tolerance is relevant because traditionally there was a thought that no DNA reactive chemicals should be allowed, a one-hit theory that if you're exposed to that, that's a bad thing. So zero tolerance is always desirable when you're talking about genotoxicants or carcinogen-causing agents. What's been interesting, and I'm going to focus on acrylamide in particular, but I listed both acrylamide and furan, is that both of these are genotoxicants. Both of them are carcinogens. Acrylamide, you may be familiar with, was discovered around 2002 as being present in food, and there's been a lot of work. And FDA and EFSA both have implemented what are called market basket surveys, where they pull products off shelf and analyze for the amount in there. You can go to the website, you can find that, and you can see by product type and by brand type how much of these chemicals are in there. What's unique is if you think about using fire, we've been exposed to these chemicals forever. And so something is different when you're exposed to these in mixtures. They also affect taste. And as many analytical chemists in the room might be able to attest to, if you want to lower one of them, because this is a complex reaction, you may increase another. So implementing zero tolerance or trying to get rid of one can really impact the safety profile of another. And acrylamide's a great example. So if you try to lower acrylamide in coffee, you increase furan. So what I wanted to share in the context of this roundtable is that the European Commission basically has set precedent in implementing some performance standards, really. So there's a lot of pressure to lower the level of acrylamide in foods. This regulation has been adopted. It was adopted in 2017, and it establishes, I didn't put the values up here, but they're on the order of 100 to 500 parts per billion acrylamide in foods. The spirit of the approach is that we will start with a certain value of acrylamide and continue to lower it, knowing that zero is impossible. You can't have the finished product. Think of coffee, think of potato chips. You're not going to have a cooked product. It's impossible, basically, to get to zero in these products. However, the EFSA working group felt that we need to try to encourage the industry to lower them. So this is very novel for the toxicologists in the food industry to have performance standards to work against. And it's interesting too because it's contradictory. I don't know if many of you are familiar with Prop 65, but there are values set in Prop 65 that are based on cancer endpoints in animals, and these values don't align at all. And as you work on your food safety plans and under FSMA, I'm sure the question of heat-formed toxicants comes up. So I'm kind of just throwing a whole bunch of information out there for you to chew on. I don't think there's any right or wrong, but I wanted to share that it's been very interesting in the last couple years that we are seeing this movement towards a performance standard philosophy on acrylamide. Furan may be next. There seems to be a lot going on with furan. And I think I will stop there and we'll move on.